Welcome. Let's create a rational function that has the following characteristics. A whole at the value of x equals negative 5, 7, a vertical asymptote at x equals negative 6, a 0 at 3 divided by 4, and a horizontal asymptote at the line of y equals 1. For the way that we're going to do this, we're going to be creating a rational function, one characteristic at a time. So let's take a look at our first characteristic, a whole at the value of x equals negative 5 over 7. Well, when do we encounter holes in a graph? Well, remember that holes, they occur at the factors that get canceled out whenever we are simplifying an expression. So if we want to have a factor where x is equivalent to negative 5 over 7, one way of finding that factor is to write the value and solve for 0. So let's start by multiplying 7 on both sides. 7x equals to negative 5, and let's just add 5 to it. So the factor that we will use is the expression of 7x plus 5. So let's place that in the numerator, and let's place that in the denominator. Now let's move to the next characteristic, a vertical asymptote at x equals negative 6. Well, vertical asymptotes, they occur at factors that only make the denominator equal to 0. If we want to have a vertical asymptote at the value of x equals negative 6, well, how about we get the factor of x plus 6 and we only place it on the denominator? That's going to guarantee that the denominator, it is 0 at this specific location. So now let's look at the next characteristic. We want to also have a 0 at the value of 3 divided by 4. Well, zeros, or solutions, they occur at factors that only make the numerator equals to 0. Well, what factor can we use if we want to make sure that we have a solution at x equals 3 over 4? Let's use the same idea. Let's write down the location that we wanted to have a solution, and let's solve for 0. Let's start by multiplying 4 on both sides. Now we are going to get for x equals to 3, let's take away 3. So now we have the expression of 4x minus 3 equals to 0. Well, this is the factor that we are going to consider, 4x minus 3. That expression guarantees to have an output of 0 when x is equivalent to 3 over 4. So let's only place that in the numerator. So now let's move to the last characteristic. We want to make sure that we also have a horizontal asymptote at y equals 1. Well, horizontal asymptotes, they occur at a specific location when the leading coefficient of the numerator divided by the leading coefficient of the denominator, it is equal to the location that we want, which in this case, we wanted to have the location of 1. Well, let's look at what leading coefficients we have with the characteristics that we have so far. If we expand the numerator, we're going to obtain the expression of 28x squared minus x minus 15. And if we expand the denominator, we're going to get 7x squared plus 47x plus 30. And right now, when I look at the leading coefficient of the numerator, which is 28, and we divide it by the leading coefficient of the denominator, which is 7, that division, it is not equal to the value of 1. Well, let's fix that. How about if I get the whole denominator and I multiply it times 4? Well, when I do that on my first distribution, I'm going to get 28x to the second, and I really don't care about the rest because I only care for the leading coefficients, their division, to be equivalent to 1. So let's put that 4 in our rational function. That is going to guarantee for the leading coefficient of the numerator, when we divide it by the leading coefficient of the denominator, to be equivalent of a value of 1, which is the last characteristic that we wanted to have. And now this rational function that we have here at the bottom, will satisfy all four conditions. We know that we have a whole at x equals negative 5 over 7 because that factor will cancel out. We know that we have a vertical asymptote at x equals negative 6 because we have the factor of x plus 6 only on the denominator. We know we're going to get a 0 at the value of 3 over 4 because we have the factor of 4x minus 3 only on the numerator. And we have shown that we're going to have a horizontal asymptote at the value of y equals 1 because the leading coefficient of the numerator divided by the leading coefficient of the denominator, it is equals to 1. So how about we graph this function and we visualize our final result? So let's graph the rational function that we created. And let's look at one characteristic at a time. Do we have a whole at negative 5 over 7? Well, we cannot really see it on the graph. Well, let's take a look at the table of values. And notice that at the location of negative 5 over 7, it is undefined. So we definitely have a hole in there. Do we have a vertical asymptote at x equals negative 6? We do. We can see it there. Do we have a 0 at 3 divided by 4? We do. 3 divided by 4 is 0.75. Do we have a horizontal asymptote at y equals to 1? We do. We can see it there. So all four characteristics are here. Then we have created the correct rational function. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.